Let's start it off. Reflections. Make sure we can reflect through x-axis, y-axis, horizontal or vertical. Ready? Horizontal line. Y equals a number. That's a horizontal line. X equals any number. That's going to be your vertical line. All right. You might have to find the line of reflection. Here's 2 points. Where's the line of reflection? Write the equation for it. Ready? What happens if I give you this? Tell me the rule. Reflection through y equals x. What do I need to do with my coordinates there? Y equals x. I'm going to flip the coordinates. Yep, flip the coordinates. I'm going to flip them. And then if I go through y equals negative x, I got to remember that rule, and that rule would be flip and change the sign. All right, all good reflections. Lowercase r, it's a rigid motion, doesn't change size or shape. Translations. All right, let's go over the 2 notations in case I ask for them tomorrow. Notation number 1 is function notation. Function notation. X comma y goes to x, we can make this up, plus 2, y minus 6. That's function notation. So that would be right 2 down 6, right? Right 2 down 6. Vector notation. That's in the little arrows here. I just put the numbers 2, negative 6. That's vector notation. Okay, that's vector notation. And translations, up, down, left, right. You just got to give me the number of units. Okay, so far. All right, rotations, that's capital R. Capital R, clockwise. That would be like a rotation of negative 90. Any negative degree measures, I go clockwise. Counterclockwise, that's positive degree measure. So I'll put, I don't want to put 180. It could go either way. So I'll put 270. All right, rotation of 270. That would be counterclockwise. Any positive degrees, I'm going counterclockwise. Any negative ones, I'm going clockwise. Dilations, I won't go over because that's what we've done the last 3 class periods here. Dilate a point. It could be around the origin, or it could be around any point. All right, be prepared for both. Around the origin, you can multiply. Around a point, you got to do slope. Dilate a line like we did yesterday. Make sure if the point's on the line remains the same. All right, if it's not, the 2 lines remain parallel. Composition, how do I perform them? I got 2 up here. How do I perform a composition? Which one do I do first? Go ahead, Iris. Right to left. So I do the rotation, then the reflection. So remember, we do these right to left. Okay, right to left. Compasses tomorrow. Okay, compasses tomorrow because I'm going to ask. We've only done 1 construction. It's a dilation. And look, scale. It's not going to be a shocker, right? The scale factor is either going to be 2 or it's going to be 1/2. All right, so be prepared for both for that construction. I will ask you for prove 2 triangles congruent using rigid motion. So let's go over the wording I'm looking for full credit tomorrow. So let's say, I'll just start making this up. Reflection. So here you go. Let me start right from scratch here. So triangle ABC is reflected over the y-axis and translated left 4, down 2. So that's what you guys figured out on your own. I gave you triangle ABC and A prime, B prime, C prime. You did a little messing around and you're like, oh, I reflected over the y-axis and translated left 4 down 2. Now what do you tell me? Reflections and translations are rigid motions. Yep, I'm just making sure we got all the wording here that we need. Write that over again. So reflections and translations are rigid motions. All right, keep going. Which? What are you going to tell me about them? Are rigid motions which? What do rigid motions do? Guys, I just want to make sure you got the correct wording tomorrow, because if we're missing something, I can't give you the credit for it. Our reflections and translations are rigid motions which preserve. What's it preserve? Distance and angle measure. And whatever word you want to use there, I'll just use thus. Triangle ABC congruent to A prime, B prime, C prime. Whew. Just want to make sure we're good with the wording. But again, remember, you're going to have to find the rule, right? You're going to have to find what transformations move ABC on the prime one. Same versus opposite orientation. That's the order of your vertices. That's the order of your vertices. So same orientation, ready? Translations. Rotations. Opposite orientation, reflections and glide reflections. That'll change orientation. Okay, that's not. Do my letters go clockwise or counterclockwise, and do they stay that same way, or do they go opposite? And then what about, and there's a question on invariant points. I just want to make sure. Invariant, remember, those are points that don't move after a transformation. So points that do not change after a transformation. Is there anything at all that I can go over more detail, or you want to try a problem with? Better know how to do that construction tomorrow. There's one on there. Okay, there's one on there. And it's either going to be a scale factor of 2 or 1/2. Nothing? All right, there's not even a need for Chromebooks to come out today, because the answers to your review questions are in the back of your packet if you haven't seen that yet. You can skip around. You can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do the odds, do the evens. Skip around a little bit, but the answer key are in the back of your packet. All right, so that's all we're going to do now until 8:24 is just grind away. All right, if you got a question, please call me over. There's a couple questions that I X'd out. Obviously, just skip over them. All right, that we didn't do those types. So, all right, go ahead. Let's go grind away here. A lot of practice. And I'll leave this up on the board. But again, this is up on